Hey guys, welcome to the Nerd Vine. This is Pradipta Chaudhary, and I've been working as a data and MLOps engineer for the last couple of years in the industry. So, as a MLOps engineer, my primary task was to enable and optimize the process of deployment of data science applications and make them production ready, make them mature. And as a result of this, I used to work with a lot of data scientists. I used to understand the problems, I had to solve a lot of those, enable CI/CD pipelines, automate the retraining processes, and like basically anything like establishing best practices and making it more optimized for data science applications to move it production. So basically, the motivation behind this series of videos about data science lifecycle and its various components is to help fellow engineers and save them some trouble and some time that I had to go through. So, as part of this introduction, we'll go through a typical data science lifecycle in an organization or industry. So whenever you start a data science application, there will be a problem. So first step is understanding the problem that you are trying to tackle. So there would be a business user, there would be some business SMEs that would come to you with a business use case or a use case that they want to solve using data science. So first step is to understand the problem, ask relevant questions, establish the scope of the data science application that you want to build. So you need to ask the relevant questions: what kind of data are being captured, what kind of errors they are experiencing, what data is there to support those errors, what kind of patterns emerge, and all those questions you need to ask, set a scope. And with this particular scope in mind, we need to like provide relevant suggestions to the data science, to the business teams. So like why do we need to provide relevant suggestions? So basically they are business users, they are business SMEs, so they would have tons of knowledge about the products, their softwares, or something that I'm working on. So they might not be that proficient in data science. So we as a data science scientist, it's our role to provide them relevant information on what can be done, what can't be done, and all those scenarios. We are the one who need to we need to give them relevant suggestions on what can be done, what makes sense, what's relevant on those scenarios. So after you know the problem that you're trying to tackle, you have some answers on what needs to be done. Then the second step is you need to gather the relevant data. So in a industry setup or in an organization setup, you would find data spread across multiple data lakes. So you need to find the relevant data source where your data resides. You need to get relevant accesses. You need to understand the schema. You need to get a data dictionary from business SMEs. So basically, data dictionary is dictionary explaining each of the columns of a data set and like what are the subcategories there in each of the columns and all those things. In some scenarios, you might have to even mine the data. Like if sometimes you need to collect the data from some websites. You need to do some web scraping, do some mining, and gather the data before you can work on it. So once you have the data, once you have gathered the relevant data, then the next step is you need to explore the data, clean the data. For example, if it's a log data, you might need to clean it with regular expressions to gather relevant information out of it. Then you need to do feature engineering to extract further relevant informations, to do dimensional reduction, and like whatever might be required to prepare the data for the modeling. We need to do all those things. So once we are done with the data engineering step, we'll be having a data set where we can go ahead and we can apply our data modeling to. So this particular data set, we generally call it as an analytical data set. So this analytical data set is the data on which the modeling algorithms will be tried on, will be applied. So now once you have an analytical data set, you have to choose what kind of algorithm you need to use, whether it's a supervision algorithm or regression algorithm or segmentation algorithm, like what kind of problem uh, um, or algorithm you need to choose depending on the data. You have to decide on that. You have to tune the hyperparameters and do all those things. So after you have a working model ready, you would what the business SMEs might do is they would give you a test data, and they would ask you to generate the output based on your model for that test data. You would generate the output. You would go to the business SMEs. They would give you some feedback. You would come back and you would tune your model based on the feedback. You would come back, go back to them. Basically, there's an iterative process that happens. So once you have a fine-tuned model, uh, so like once you have fine-tuned model, you need to also use other appropriate strategies depending on your use case relevant to the model. So, for example, let's say we need to predict when a server might go out of memory in the next 4 hours. So, say we have last 10 hours data. Based on the last 10 hours data, we need to predict the next 4 hours data. So, it's time series model. So, in this particular use case, what we need to do is we can schedule the model to run every on every hour and do the prediction for the next 4 hours. And depending on and once we have the actual data for the next 4 hours, we'll be comparing with the output that we received for the from the model output that we designed. So we'll do this over a period of say 7 days or a couple of weeks, and we'll be having getting us a validation, or we'll be evaluating the model how it is working in real time scenario. So once you have a fine-tuned model, it's perfectly working, and you are happy with it, you would have to go ahead and you would have to deploy it, and you would have to do all the required toolings around it. And so why this particular step is important, this model deployment and DevOps step. A lot of cool work is done in the world with respect to machine learning and AI, but not very few of those actually go ahead and go into production. So and go into maturity that is required. So to enable this step, we need to have all the required toolings, have CI/CD pipelines, DevOps uh, pipelines. We need to do the required dashboardings, create APIs for mobility, schedule the retraining, and do all those things. So us in the series, what we'll do is we'll deep dive into each of the topics, and we'll see with the emphasis being how to make them production grade. So each of those components have like each of the steps have a lot of components in them. We'll be going into each of those. In the first part of the series, we'll be concentrating on the model deployment and DevOps part. So, what are the steps that are involved in model deployment and DevOps? So, one of the steps is model retraining automation. So, what is model retraining and why is it required? So now you have a working model, but how long will that model be effective? So say you let's reconsider the example of the memory consumption. So let's say you have a working model deployed and everything. It's working perfectly for 1 month, say 2 months, and so. But after 2 months, you start seeing that the model is starting to behave differently than it should. So you try to debug and see what's going on. So you see the data that is coming now is significantly different from the data that was coming 2 months back. So in these scenarios, the model that is running now becomes obsolete. To avoid this particular scenario, what we do is we retrain the model on an appropriate schedule, say 1 week or 2 week, depending on how significantly the data changes on what time, on what schedule. So to do model retraining, we can use tools like Airflow, Argo. There are tons of tools that are available on open source enterprise tools that are available that you can use for this. And depending on the output of your model retraining, if it's a pickle file or some file data. You can store it in an object store. If it's tabular data, flat files, or RDBMS, if it's a graph data, graph DB, if it's a NoSQL data, MongoDB, or something like that, depending on the output of your model, you want to store it there. So then the next component is the API dashboard and visualization component. So this particular step allows enables the mobility of data science applications. So now you have a perfectly working model. It's working. It's giving really accurate predictions and all. But you don't have any API. You don't have any dashboard using which users can consume the your data science applications. So it's of no use, right? So to enable this particular mobility process, we develop relevant APIs using production grade API frameworks to dashboards and create graphs and all those things. So in this step, it's very necessary to track the logs of the API or the dashboards that you're creating into a log warehouse, collect telemetry data on how many users are using it, and also what's the processing time and all those details. So we'll be deep diving into each of those component in this in the first part of the series. So the next component is the deploy and CI/CD automation part. So now you have your API ready, you have your model retraining script ready, you have all those steps ready. You would want to deploy and enable the version control and CI/CD on top of it. So to enable the step, we can use version control like GitHub, or if you're using AWS, something like S3 buckets to manage versions or something like that. And we'll use CI/CD tools. So different platforms come with different policy of CI/CD. So depending on the platform, you need to use that relevant CI/CD tools. We'll see a couple of we'll see for a couple of platforms in the series. So the next component is the metrics tracking. So we need to track the necessary metrics, the CPU consumption details, some memory consumption details of the model retraining, how the API is performing, and all those details. Apart from that, we need to collect how the model the model that is being retrained is working. So we need to get the quality of the model, do visualizations around it. We can use tools like MLflow and all those things, or some other tool to get how well the model is being treated. So these are the major components in model deployment and DevOps. So in the next video, we'll deep dive into each of in the next part of the series, we'll deep dive into each of the components, and we'll see in more details about those. If you like this video, share with your colleagues, engineers, friends who might be interested, subscribe.